Alright, now in the last video we talked about how to solve basic exponential and log equations. We do know that sometimes though we can have more than one exponential in a problem, or we can have more than one log in a problem. So how do we handle solving if we do have more than one of each of the functions? So things that you want to remember is when we say isolate, it's just like when we said isolate with radicals. If you have more than one log or more than one exponential, when we talk about isolating, we're isolating them from each other. So that means that you want to have them separated by the equal sign. So when we say isolate, that means we need to move the logs so that they're on opposite sides of the equal sign, or move the exponentials so that they're on opposite sides of the equal sign. So we want to isolate them from each other. Another thing that you want to remember is if you have the same log or same exponential base on both sides, they cancel. If we have the same base for our log or the same base for our exponential on both sides, they cancel. And that's awesome, because if they just cancel out, then we just solve whatever is left. So the same log or the same exponential base on both sides, they cancel. So we want to remember that. So when we're looking at problems, and there are some that look as simple as this, but when you're looking at something like natural log of 3x plus 7 is equal to the natural log of 2x minus 18, when I'm looking at this and I go to that isolate step, well, both of these logs are already isolated from one another. And then I'm remembering, if I have the same base on both sides, they just cancel. So if I have log base e over here and log base e over here, then they are just going to cancel each other out, and all I'm left with is 3x plus 7 and 2x minus 18. And then I just solve whatever equation is left here. In this case, that would be fairly simple, so I'm just going to subtract 2x from both sides, and that's going to give me x. If I subtract 7 from both sides, I get negative 25. So, if it's the same log on both sides, then they just cancel out. With logs, the only other thing that can cause drama, because generally, folks, for this level, you're going to have logs that are the same base. The only other problem you might have is if you have 2 or 3. If you have 3 or 4 logs, one thing you're going to remember is that we can condense. That's why we learned expanding and condensing. We can condense logs so that we do just have one log on both sides. If I have common log of x squared is equal to log of x plus 1 and plus log of x plus 2. And I'm looking at this as a problem. Well, as far as isolating, well, the logs are already on opposite sides of each other, but I have 2 of them on this side. And so when I'm isolating, I'm like, okay, well, this side is isolated, but over here, I really need to condense these 2 logs together. And so I have to remember, okay, addition becomes multiplication. And so this is going to be log, but I need to multiply what's inside of here. I need to do x plus 1 times x plus 2. So when I multiply that out, I get x squared plus 2x plus 1x plus 2. So this is going to end up being log of x squared plus 3x plus 2. On this side, I have log of x squared. Now that I have multiplied what was inside these logs, and I just have one log on each side, they're both log base 10, so they're going to cancel each other out. I end up with x squared is equal to x squared plus 3x plus 2. And this is very solvable, because if I subtract x squared from both sides, the x squareds actually cancel out. I get 0 equals 3x plus 2, subtract 2 from both sides. At this point, we're at that step 3, finish solving. That'll give me 3x is equal to negative 2, and when I divide by 3, I get that x is equal to negative 2/3. So again, logs, isolate them. If I have more than 2 logs left on the side, I can, of course, condense them. And that's why we learned if it was subtraction, we would divide. If there was a number up front, we move it up into the exponent. All of these are things that we can do to condense to make these things easier. But if I have the same log with the same base, they literally just cancel out. I do, however, have to have just one log on both sides for that to work. Exponentials. Again, if I have more than one of them, if I have 2 to the 3x plus 4 power is equal to 2 to the 2x minus 7 power. When I'm looking at a problem like this, isolate means to make sure that they are on both sides of the equation, that there's an equal sign in between them, and that is the case. 2, if we notice that it is the same base, then they just cancel out. This is 2 to the something power, and this is 2 to the something power. So since they're the same base, they just cancel. And all I'm left with is 3x plus 4 is equal to 2x minus 7. And that is just something that I can then finish solving. When I subtract 2x from both sides, x, and then I've got to subtract 4 from both sides, so I end up with x is equal to negative 11. The same bases cancel out. The drama comes when they don't have the same base. And so that's something that we want to talk about, is what happens when you do have two exponentials, but they're not the same base. So let's take a look at a problem. If I have 2 to the x plus 4 power is equal to 8 to the x minus 5 power, and I'm wanting to solve this exponential. Step number 1 is to isolate, and that's done. The exponentials are on opposite sides of the equal sign. Now, step 2 was either they're the same base, or we had to rewrite it as a log. And so that's what we want to talk about now. They're not the same base. So I can't just cancel out the bases. I can, however, still rewrite it as a log. And so that's what I'm going to have to do. And the thing is, you just have to pick one of the bases to use as your base of your exponential. It doesn't matter which one you choose. I generally choose the one on the left just because it's the one on the left, but that doesn't mean that that's the one you have to choose. You could choose the other one. So I'm going to rewrite this as a log. So a base is a base is a base. So my base is going to be 2. So I've got log base 2. The exponent is what it's equal to. So I've got my base, and then my exponent is x plus 4. And then whatever it's equal to is what goes here. So this is going to be 8 to the x minus 5 power. Now you may be thinking, how does that help me? Now I have a log and an exponential. Well, it does. And this is where we want to remember our properties of logs. This is one of our properties of logs. We had a rule that said that if there was an exponent inside of a log, that it can move to the front of the log. It comes down out of the exponent. And so that means I can move this whole exponent, whatever is up here in the exponent, can actually move to the front. So now I'm going to have x minus 5. Now the whole thing, do notice I put it in parentheses so I keep it together, moves up to the front, and it's being multiplied by log base 2 of 8. And again, a lot of students are like, but how does that help us? Well, the beauty of it is log base 2 of 8 is something I can get a number for. That is something I can type in my calculator. It might be a decimal, but it's still a number. And when I have a number, I can then distribute that number to go times everything over here, and then I've got an equation that I can actually solve. So I'm going to go to my calculator for a moment, and I'm going to figure out what log base 2 of 8 is. You may actually know that off the top of your head. 2 to what power equals 8? 2 to the 3rd power. This one actually did turn out to be something that had an even number. So this is 3 times x minus 5. So if I distribute that, and if you don't remember logs, don't forget your change of base formula. Log of 8 divided by log of 2. That's where that 3 came from. It's what log base 2 of 8 is. And so when I distribute that, I do end up with 3x minus 15 is equal to x plus 4. This is something that I can handle actually solving. So I'm going to subtract x from both sides. I'm going to add 15 to both sides. And I get 2x is equal to 19. And when I divide by 2, x is equal to 19 halves. So you still end up following that isolate, rewrite, and then finish solving. It's just that when you rewrite it, you do end up with an exponential inside of a log, and you have to move that exponent up to the front of the log.